science lesson. I'm Dr Maniscalco, and today we will look at liquids at work. In this lesson, we will state that pressure in liquids act in all directions and it will increase with depth. We'll also describe how some object will float and some other object will sink. To understand why is the case, we will make a prediction about if an object will sink or float. So we will inquire at that. We will also inquire by making observations. So we will actually do the experiment observing the object sinking or floating. And finally, we'll analyze our observation and we will try to draw some conclusions. First, we will try to address our question. How does pressure changes in liquids with depth? So if I go deeper, is the pressure going to increase or decrease? This is the question that I'm trying to answer. To do so, we have an experiment which consists in a water bottle filled with water where I pierced different holes at different heights. So what I'm going to do now, I'm going to peel off the tape that is covering the holes, and I will see if the jet coming out of that hole is going to be stronger at the bottom of the bottle, at the top, or in the middle. Okay, so I want you to pause the video, make your prediction, and then watch the video and see if your prediction was right or was wrong and how you want to change it. I will start with the middle one and see what happens. So let's open the bottle and peel the middle one. Oh, it's quite a strong jet. Let's see what happens at the bottom. Ooh, even stronger. And at the top, it's not really strong at all. Okay, so as you can see, the level of our water is going down, but the stronger jet is definitely the one at the bottom compared to the middle one. And as the height of the water column is going down, this jet here is actually getting weaker and weaker, and this one here is getting weaker as well, although it's still quite strong. So from this experiment, we can say that there is definitely a relationship between the pressure and the depth. And hopefully you will already figure out that at a deeper level we will feel more pressure. So pressure is going to be higher when we go down in the depth. Okay, so as depth increases, pressure will increase as well. Okay guys, now we're going to look at the experiment itself, and we'll check if particular objects will sink or float. What I'm asking you to do is to write down, as I will do it in my table, so you'll have to write down in your table the name of the object, the force, which in this case will be the weight, and we'll calculate it by measuring the mass first and then multiplying by the gravitational field strength. We'll just take the gravitational field strength to be 10, just to do some easy maths, but in theory is actually 9.8. Okay, so we have here a set of different cubes from different materials. They have the same volume, but they will have different mass. So I will show you how they look like, and we will record first their weight, and then we'll check if they sink or float after you would predict if they sink or float. So you need to do a prediction first before we do the experiment. So then I'm moving here. Okay, as you can see, I have the different cubes here. We'll start with this, which is a wooden cube. Okay, as you can see. So this is going to be my first object. I'll just call it wooden cube. Okay, I will measure the mass of this object using a scale. Okay, it's 8 grams. So I do need to divide this by 100 to find out the newtons. So it'll be 0.08 newtons. And I want you to predict if it sinks or floats. So I'm going to leave this blank for you to do it, and then I will fill this in with the actual result. So here I want you to tell me if it will sink or it will float. Okay, you have to do this for all the materials. So let's see what is going to happen to this wooden block. Okay, I'm back here with my wooden block, and it definitely floats. Okay, I'm going to take it out, put it down here so I know that I've done this one. So the wooden block definitely floats. Okay. Okay, and the next one I'm gonna do is this black plastic cube. Okay, so I'll call it just black plastic cube. Okay, again, I want you to think if it will sink or float, but I'll give you some more information in terms of its weight. So this is 27.8 grams, so it'll be 0.28 newtons. Okay, let's see if it will sink or float. Okay, I've got my cube here. Let's see if it floats or sinks. Okay, it definitely sinks. I'll leave it in here. Okay, the next one we're gonna do is this brass cube. Okay, so again, I want you to tell me if you think it will sink or float. I'll measure. This is 136.17 grams. Okay, so that would be 1.36 newtons. Let's see. See if it floats or it sinks. Sinks. Okay, so this one sinks and this one sinks as well. Last one, but not the least one, we'll do this transparent plastic cube. Okay, so we're going to measure the mass. 19.72, so it's going to be 0.20. Okay. Floats or sinks. Sinks as well. So we're right here, that sinks as well. The next experiment will include object that will have the same mass, so the same weight, but will have different shapes. So we'll have to analyze if this makes a difference or not. So we'll get rid of the cubes. Okay, and as you can see here, I have paraffin as a blob and paraffin as a sheet, and same thing for wax as a disc and wax as a sheet. Wax is what candles are made of. And then I have some pieces of oranges, okay, and this is just like a wedge with the peel on. So I'm going to put it here so you can see all the objects. And then I have another piece of orange, which is instead a bit more like a slice, and the peel has been removed. All these objects will have the same mass. We will measure the mass first, and then we will see if there is a difference in terms of floating and sinking. So we'll start with the paraffin. And we'll start with the blob first. I'm just going to move this up so you can see. Okay. It's 23.43, so it's 0.23. Okay. Then I'll just put it back here. Then the sheet. Okay, look, there's something going on here because we put some water on. So what we need to do, if we want to have an accurate measurement, we do need to dry this and possibly re-zero it. Okay, so as you can see, this is paraffin sheet, same mass. Okay, might vary a little bit, but is very, very similar. This is the wax blob. And this is 0.09 newtons. Okay, so we measured the wax blob. Now we will measure the mass of the sheet of wax. Okay, it's a bit different, but not as much difference. So it needs, the weight is going to be just take a 0.10. Okay, which is slightly different, but not as much. So we are fairly happy with it. We just need to kind of take that into consideration. And this is gonna be called wax sheet. 2 E's. Okay, so what we're gonna do, we're gonna look at the behavior of the wax bob and the wax sheet, and I want you to predict again if they sink, so which one will sink, which one will float, if they both sink or they both float, and I will then write here what actually happened. But before we go there, I will just measure my last type of object that I will investigate today. So we have a boat-shaped plasticine here, okay, and this is 22.59 grams. So I'll just write that 0.22 newtons as weight. So this is my plasticine boat. And then I have a cube here, kind of cube shaped, and this is again made of plasticine, and it should be the same mass, but it's a different shape. And yes, this again is slightly different, but not as much. So this is going to be 23, okay, because I round up. Okay, so this is the plasticine cube. Okay, we're all set to go in terms of our filling our table with the weights. Now, as I said, for each of of these you need to predict before you look at the experiment if they sink or if they float. I left it blank because I want you to do it, but I will go and fill this in after each experiment. Okay, we'll start with the paraffin blob and the paraffin sheet. Okay guys, I have here my paraffin blob and my paraffin sheet. Let's see what happens with the first one. Okay, it's definitely sinking. Okay, so it did sink. And now let's see. I need to be careful putting the sheet up in the correct way. And I'm just waiting for a minute. Just a few seconds, see what happens. But it does look that in the sheet, even though they have the same weight, actually the paraffin sheet is floating rather than sinking. So interesting, because before we thought that the difference in sinking and floating depended on the weight of the object, but actually now we can think about that it's not only depending on the weight, or maybe not always depending on the weight. Actually, the shape has an effect as well. Okay, I'm just recording the results here. So paraffin blob sinks, paraffin sheet floats. Now we will have a look at the wax. Right, so the wax, we'll start with the blob again. Looks like it's floating. Maybe this time the sheet then will sink, because before we had the opposite, the other way around. We'll see. Actually this looks like actually both flow. Okay, well, so we definitely found out that the weight plays a part, but the shape also plays a part. So maybe the weight here plays a part more than the shape. While in the example before with the paraffin, the shape actually played the part more than the weight. Okay, have a think about that. Okay, we're recording our results. Wax blob floats and wax sheet floats as well. Okay, the last thing we need to investigate is the plasticine. Now I made the plasticine in the shape of a boat, as I've shown you before, and then I have just like a cube of plasticine, which kind of a cube that has the same mass as this boat. So here it's quite of a key experiment, this one, because this will actually explain or not, depending on what results we get, why boats float and possibly don't sink. We'll hope so. Okay, we'll start with the cube, and let's say hopefully you've done your prediction before looking at this. Yeah, the cube definitely sinks. Now we don't want our boat to do the same. Okay, so let's see. Wow. So the boat-shaped plasticine is actually floating. Okay, and I can move it around and it keeps floating. While the cube that has the same mass and the same weight is at the bottom of this beaker. Okay, so have a think about the implication of this, and hopefully now you will be able to explain better why even both are very massive, they still float. Okay, we will just record our last results. So float and sinks. Okay, so this is the experiment we've done in part 1, which is same shaped objects but different masses, okay, different materials, different weights, because they have different masses. And these was objects that have the same mass or very, very similar mass, but they have different shapes. And I want you to look at this and try to make some conclusions. So analyze your result and make some conclusion from it. You have some question here where you have to describe your observation, the one that you recorded in your table. Describe the patterns for part 1 and part 2. And I want you then to think about why some object do you think float and some object instead sunk. And in the last 2 questions, you have to draw a force diagram, so the one using the arrows to show the forces acting on the object. For question 5 instead, you need to do some calculations, and you do need to calculate the water pressure acting on the toy boat. And by water pressure we mean the force acting on the surface of the toy boat, and which is named here as upthrust. So today we looked at liquids at work. I'm Dr Maniscalco, and thank you for watching this newest practical science video.